we will be in this Jom Heboh SPM together. I would be focusing on this. All right, resolution of forces in bahasa is called katanya sama juga. Okay, resolusi daya. Okay, maksudnya daya dipecahkan. So, all right, in the past I already have mentioned. So I'm going to show you the relationship between these two, so that you are aware. All right. So, okay, let's take a look at the question. All right. The question says system in equilibrium. Jadi maksudnya, okay, sistem dalam keseimbangan. Alright. So in other words, sistem tidak bergerak. So, alright, sistem tidak bergerak. Okay, object not moving. So what we do is, first step is always, I show you the most used method. Okay, we call resolution of forces. Okay, iaitu daya resolusi, kita pecahkan daya. See what we do? Alright, kita hanya pecahkan daya yang condong. Only the slanting one. So this is slanting, we split it. This is slanting, we split it. Okay, kita akan pecahkan. Jadi, alright. Jadi saya akan tunjukkan di sini, bila kita pecahkan, kita akan ada satu, okay, Fx, dan kita ada satu kat sini, alright, Fy. Okay, saya akan tandakan di sini Fy. Alright. Tapi sebelum itu, biar saya masukkan sudut. Okay. So, kalau kita ada sudut keseluruhan 120 here, alright, maksudnya, alright, it is actually 60-60. Alright, so if I were to put right in the middle, tengah-tengah ini, alright, so we have the red one, okay? We have, let's say, I'm going to put, okay, alright, the red one here as, okay, the red one here 60. So if the red one 60, alright, if the red one is 60, that means this is going to be 30. So we are focusing on 30 degree. I would do resolution on the other side. Okay? Di sini juga. Okay? Kita akan pecahkan. So, kita tengok. Alright? Bila pecahkan, kita pun ada satu Fx di sini. Alright? Dan satu lagi Fy kat sini. Okay? So, saya akan tulis nilai yang sepatutnya kita ada. Alright? Okay. In the first session, you already have learned. Okay? You already have learned. Okay? The reason I use 30 degree is I always tell students to use horizontal angle. Alright, this is the meaning of horizontal angle. Okay, alright, the meaning of horizontal angle is the angle is made with horizon. Okay, we don't use vertical. Vertical means from here to here. Alright, vertical means what? Tegak. Okay, sudut tegak. We don't use this vertical angle. We use horizontal angle. Got it? Horizontal angle, sudut, okay, ufuk kita kata. Alright, can we continue? So, we already have learned that Fx is going to give you, alright, give you, okay, T cos 30. Remember that? Alright, and this is, if Fx is T cos, if Fx T cos, then Fy will be T sin. Remember? Okay, itu yang kita guna lah. Alright, Fx, bila Fx adalah mengambil nilai T cos, alright, T cos 30, jadi Fy akan mengambil nilai T sin 30 darjah. Alright. So after this method, you find it very easy. Okay. I will show you 4 kaedah. Okay. Okay. Untuk mendapatkan jawapan. Gunakan kaedah berbeza. Okay. Alright. Jadi, okay, anda akan dapati, alright, daya sebelah kanan akan menghapuskan daya sebelah kiri. Okay, done. Okay. So and then you learn that, alright, okay, daya ke atas, okay, daya ke atas, in English, upward force, will equal to downward force. So, downward force, understood, it will be the weight of the object given already. Okay, berat object, okay, which is 10 Newton. So, what we do is, we are going to put daya ke atas, okay, upward force. Okay, so we have one upward force, Fy, another one more upward force. So, we have actually 2 Fy. Alright, ada 2 daya ke atas. Jadi, kita ganti ke dalam. Alright, kita akan mendapati nilainya adalah T sin 30 darjah. So remember you have these 2 kat sini. If you don't put the 2, it's wrong. So to further solve the problem, alright, we will get your sin 30 from your calculator. Then you will be able to get a half. Alright, 1/2. And you know that, okay, we have done this in the past. So today I'm going to show you, alright, okay, another few more methods to get your answer. So we know that T is going to be 10 Newton. Alright? So this is step number 1. This question is actually similar to this question. But many students, when they see this question, they already not very sure what to do. Okay, they are not sure what to do because probably they got probably they got cheated. All right, they do not know what to do with this. Jadi sebenarnya sama. So what we do is we will split this into two again. All right. Okay, so one here, all right, and one here. Okay, so understood. Okay, up here fx, fy, kat sini fx. Okay, all right, and understood. The other side sama juga. All right, okay, sama juga. We split the same method. Okay, we split, then we're going to have, okay, fx here, fy here. So drawing can be different, but you have the same, we call it system. All right, this is the weight of the object. Okay. So I put it in, this is t, this is t. When I put it in, I'll get the same thing. This is also t cos 30 degree. And fy, all right, will be t sine 30 degree. All right. And I'm going to do the same thing for fx here, which is going to be a t cos, again, 30 degree. All right. And up here will be equivalent to, all right, t, okay, this one will be your fy, will be a t, all right, sine 30 degree. So similar explanation. All right, but this one you'll notice that your fx to the right will cancel your fx to the left, so cancel off. So we have two fy going up. All right, this is one of the fy, this is one of the fy. So understood, we're going to write the same thing. You will end up having the same thing. All right, upward force equivalent to downward force. All right, so I'm showing you this so that you won't get we call it cheated, okay, or tricked, okay, by different method of questions. All right, actually they are the same. So if I put it in, you notice that the format of what you're going to write will be exactly the same on the right side. Okay? Yeah? So first method is resolution of forces. Okay? So remember, the answer is 10 Newton. Huh? All right? The answer is 10 Newton. So I am going to show you, okay, a few more methods. Okay? So that if some of you say that, oh, I don't really like this method. All right? Okay? I don't really like this method. I find it is so hard. Okay, so fine, doesn't matter. All right, you can use another method. Okay, I will show you a total of 4 to 5 different methods. Okay, so that you won't feel stressed about doing the same thing. So I'm repeating what we done just now. Okay, all right, huh? So this is the first method. The second method is, of course, we are going to draw. Okay, we're going to draw diagram. All right, we're going to draw diagram. So I'm going to erase this. I'm not going to use this as our diagram. I am going to use this as our diagram. Clear? Okay. Yeah? So the second method is you will need to draw a triangle. All right. You need to draw a triangle. Okay. See how I draw the triangle? You can draw this one first. All right. This line going up. So I'm going to draw. I'm going to draw this line going up. All right. Going up. Okay. So you follow the direction of the tension, okay? All right, T. Then after you reach here, which is actually this point, you will continue to draw this one upward, okay? So you will end up like this, all right? You end up like this. Clear? All right? This is also going to be T. This is a second method, huh? Second method, draw triangle. All right? Okay? Kaedah kedua, okay? Untuk melukis segitiga, okay? All right? Okay, I write down here, kaedah kedua, okay, lukisan segitiga. All right, segitiga. Okay? And then the next one is you need to understood, look at the shape of the triangle I draw here. You need to complete the triangle. All right? If you don't complete the triangle, all right, you cannot apply what we want. Okay? So we know the other one is actually W. W going all the way down. All right, I've given to you the value of the weight berat objek ini, all right, diberi sebanyak 10 Newton. So I have to move this W here. If I don't move it here, I cannot complete the triangle. So if I cannot complete the triangle, I cannot continue doing the question. All right, okay, huh? Boleh? Now some of you will think that, oh, what if I were to use this one and draw? Boleh. Then use this one and draw, then you will probably be having like this, okay? All right, here. It's actually boleh. You will actually draw a parallelogram. This is activity, okay? Drawing parallelogram, okay? Then you will bring this one over here, okay? Do you see notice or not? You're going to draw parallelogram, okay? So, okay, I wouldn't want you to show too many triangles, otherwise you get confused, Okay? Let's take a good look. Huh? This line is this line. And we know this angle is 30 degree. Betul? Alright, 30 degree. So if this is a 30 degree, alright, this is also going to be a 30 degree. Okay? Do you see a Z there? No? Alright? Okay? Do you see the angle there? Alright? Okay? If you remember what you learned in Form 3, alright? You remember what you, okay? In Form 3, you have this triangle. Alright? Okay? If you have a Z shape there, alright, this angle and this angle will be the same. Betul? Right? Okay? Lepas itu, right? Okay? We know that the other angle, okay? The other angle also, this will also be giving you a, okay? This one, okay? This angle also will be giving you a 30. Alright? Okay? This one, if you take a good look, alright? If you take a good look, okay? This is also giving you a 30 because this is this. Boleh? Boleh? Boleh good? This side is this side. So we give it a 30. So altogether we have 60 actually. Okay? Alright? We have 60 already. Then understood. Okay? If this is 30, then understood this will be a 60. Alright? This will be a 60. Okay? And the same goes here. Alright? Because we have a 90 here. We have a 90 here. Alright? Then this side will be a 60. So what do you see there? What do you see there? Okay? Alright, so you see a triangle like this. Let's erase this triangle so that it won't disturb you, okay? Alright, it won't disturb you. Then we can use what we call another method which is known as formula sign. Alright, formula sign. Okay, formula sign. Alright, okay, sine and cos. Okay, remember what a formula sign is? Okay, you will be able to do this, okay? Alright, formula sign, we will be doing this, okay? This is a 10 Newton, alright? Okay, 10 Newton. Okay, I hope you remember your formula sign, how to do it. Okay, you study in maths. This 10, all right, over sine of this angle. All right, sine of this angle. Okay, that means you're going to go across. Okay, go across. Boleh? All right, 10, huh? All right, okay, 10 over sine 60. All right, sine 60. Okay, equivalent to, then you get a t. T over sine 60. This is also 60. All right? T over sine 60. All right? So easy. So understood. If you have sine 60 at the bottom, sine 60 at the bottom, sure you cancel it off. Clear? So understood. You're going to have your T equivalent to 10 Newton. Boleh? That is formula sign. All right? Huh? Formula sign. Okay? Then we also have formula cos. All right? Formula cos. Okay? All right, formula cos. I'm not sure whether you remember formula cos. All right, okay, in maths you got learn this. All right, you got learn this. Okay, you have learned this. I will use mathematical, what we call formula first. Huh? All right, formula first. Okay, one more thing I need to tell you. Huh? All right, when you see the arrow W weight going down, all right, okay, and then with this one T going up, all right, and another T here also going up. All right, remember? This T actually is this T. All right? Okay? This T is actually this T. All right? And this T is actually this T. Okay? All right? So if you see the triangle, segitiga, all right, with the arrow going in around, that means the system is in a state of equilibrium. Keadaan keseimbangan dicapai. Bila ana-pana dalam satu segitiga yang berterusan. Boleh? Okay? So formula cos, apa kita buat? We know we have this one as a value 60 degree. Okay? If I were to use formula, huh? Okay, just bring back a bit of your memory. All right, this is A, this is B, and let's say this is a C. Okay, C. All right? You remember in maths you got learn this? C squared equivalent to A squared plus B squared minus 2. All right? And then you put a bracket A times with a B, then times with a cos. All right? Cos, let's say, okay? Cos theta. Okay? Theta. This is your angle. Okay? All right? It must be opposite. So it must be opposite of the C. Okay? Let's say this is, or I put alpha there. Okay? All right? I put alpha. Okay? Alpha equivalent to 60 degree. All right? 60 degree. Boleh? Okay? Huh? So cos alpha. All right? You're going to use this. Remember you learned this in your maths? Okay? So now I put back our value. Huh? We know this is a W, which is a 10. All right? Newton. This is a T. All right? This is another T. So what you do is you apply this formula, all right? You're going to get what? C squared, which is this one, all right? Okay, which is a 10 squared equivalent to this squared, all right? T squared plus with, this is your A, plus with another B, all right? Another T squared, which is your B squared, all right? Minus 2 times, all right? A, which is T, and then B also T, and then you're going to have a cos, what? Okay? Cos alpha, which is a 60 degree, okay? All right? Cos alpha, which is a 60 degree, okay? Cos alpha, okay? So what we do is, kalau kita buat, you'll be getting T squared plus T squared. You're going to have a 2T squared, all right? Minus, okay? 2, T and a T. You have also T squared, all right? Cos 60. If you press your calculator, you get a half, okay? Which is going to be 1/2, okay? So you will cancel this and this. 2T squared minus T squared, 1T squared. Then you only have 1T squared. T squared equivalent to a what? Okay? T 10 squared, all right, or 100. So we know you will cancel this. Then at the end, all right, at the end, your answer, okay? At the end, your answer, you know that, okay, your T, eventually you will still be getting a, all right, your final answer, eventually you will still be getting as a 10. You notice that? All right, your final answer will be a 10 Newton, like what we did. So you have this method. Then we're going to look at another method. All right, another method. Okay, another method is we use trigo. Okay, trigo. Right, trigo. So how do we do trigo? Okay, this triangle. All right, I'm going to cut across here so that I only get this triangle out. Okay, so I'm going to draw. Okay, here. All right, draw here. Okay, I'm supposed to have 60, right? But I cut here. All right, I cut in the middle here. All right. Why do I cut here? Because I only want to use a triangle with 90 degree. You apply trigo, okay? Kalau nak buat aplikasi trigonometry, alright, anda mesti cari segitiga bersudut tepat, atau bersudut tegak. So 60 divided by 2 become a 30. Alright? And then ini juga, W which is 10 Newton, kita pecah kepada dua segitiga. Alright? The red star and the blue star. So because I break into 2, that means your W, okay, your W supposed to be 10, now carry value 5 Newton. Boleh? Alright? So ini kita buang, ini tak perlu ambil ini. Clear? So what we do now is, we are going to apply trigo. Okay? Students, trigo, alright, form 3. Alright, I think you study in form 2. Alright, trigo, maybe earlier now, the new syllabus. Alright? Okay, first thing is, we look for the T. Simple, okay? Simple question. Understood, you're going to use sine. Alright? Sine will be, okay, opposite over hypotenuse. Betul? So I'm going to apply sine 30 equivalent to, alright, be careful, if your trigo is applied correctly, don't worry. Answer will all come out. Okay? Cross multiply. Alright? Or change place. So T equivalent to a 5 over sine 30. Okay? So you press your calculator. Alright? Sine 30, it will give you a half. Alright? If you're good in maths, okay, you'll be able to, alright, reach the answer as a 10 Newton. You see or not? So every method, you are going to use trigo method, you still get 10 Newton. You use cos, formula cos, 10 Newton. Formula sine, 10 Newton. You do resolution method, okay, which is, right, you do resolution method, then you still get a 10. Okay, the last method, which is I'm going to end in maybe 2 minutes time, all right, is graphic drawing, scale drawing. In your syllabus, KSSM, all right, in your textbook, they give you, okay, scale drawing, All right, scale drawing is actually very popular in the old syllabus. All the students use scale drawing. Okay, so what do I do? All right, scale drawing meaning what? You draw according to scale. All right, I think this small space is enough for me to draw. All right, scale drawing. I will write the word scale drawing here. It's a little bit, okay, smaller. So what I do is very simple. I know this angle is 60, betul? All right, and I know this is a 10 Newton, and I know this is a 30 degree. This is a 60 degree. Yeah, do you notice that? 60 degree and a 60 degree. So if you use scale drawing, understood, you must create a scale. Let's say 1 cm represent 1 Newton. So I have 10 Newton, 10 cm. All right, so what I do is, I will draw 10 cm. Okay, done. All right, understood. When you draw 10 cm, you need to measure accurately. This must be exactly 10. Exactly from here to here, exactly 10. Tak boleh lebih, tak boleh kurang. Must be exact. Then you going to measure 60 degree and cannot make error, 60 degree. Okay, betul-betul, you assume you are an architect, okay? All right, architect don't make mistake. Here also 60 degree, okay? All right, 60 degree. So what you do is, all right, after you measure 60 degree, okay, very accurately, here also very accurately, all right, you're going to use your ruler, all right, to make the 60 degree and draw a straight line. Draw a straight line. All right, and you do the same thing also here. You're going to draw a straight line. Clear? All right, they will intercept here. All right, so when they intercept here, understood? Okay, you just put your arrow. This is your T. All right, okay, you put your arrow. This is your T. So understood? You take a good look. Okay, it's a triangle with the same angle, 60, 60, 60. So understood? Right? The length here must be the same length here. Must be the same length here. Clear? All right. Well, of course, when I draw, it doesn't look the same. All right. But never mind. I will improve a little bit. All right. I will improve a little bit on it. All right. So it will be basically, it will be something like this. It will be something like this. Okay. So this is going to be your T. So what you do is, you will put your ruler and measure. Clear? All right. You put your ruler and measure, then understood. Your answer will be a 10 cm. All right. So this T, I put your answer here. All right. I put your answer over here. This T, you are going to measure, put your ruler here or here, you will get a 10 cm, which actually represent, okay? Which actually represent a value of 10 Newton, because of your scale is 1 cm to 1 Newton, okay? That's it. So how many methods you have seen? All right, I think your teacher probably in the school will teach you maybe 1 method or 2 methods. All right, I've shown you number 1. All right, resolution, 1. All right, resolution. Number 2, okay, we can apply sine, all right, okay, sine formula, we also can apply cos formula, we also can apply trigo, all right, and also we apply what, okay, scale drawing. So all together, they are going to be, if I want to name it according to the, what should I say, the popularity, all right, resolution is the first, okay, maybe some people will apply trigo, all right, trigo will be the second one, all right, trigo, all right, okay, trigonometry, all right, okay, this is actually drawing. You need to draw triangle anyway, whatever method you need to draw, okay, right, resolution, first trigo, the third, second one, the third will be sine formula, the fourth will be cos formula, the fifth will be scale drawing. So students, you have seen all the 5 methods, all right, 5 methods how we solve problems like this, and it can be applied in all the question, all right, any question for, we call it the equilibrium application, all right. Jadi, kelima-lima langkah atau cara berbeza untuk menyelesaikan masalah boleh diaplikasikan, okay, untuk semua soalan yang melibatkan soalan keseimbangan daya. Alright, so with that, I think I will come to the end of this session. Alright, I will continue with another session, which is going to be, what should I say, I will share you some other extra, okay, question on, okay, equilibrium, all right, okay. It's already share screen, huh? Okay, all right, we come back to our part 2, okay, Jom Hebo SPM, all right, to prepare you for your exam, okay. To prepare you for an exam, let's take a good look, okay, what I'm going to show you. All right. Okay, our chapter, we start with this is our first slide. So I'm going to have a share screen, okay? So you are familiar with all this that I've put in the on the screen, all right? Basically is equilibrium of forces, ataupun dalam bahasa keseimbangan daya. So we're going to look at how the force applied in a lift, all right, lift system. Number 1, all right, okay, number 1, number 2, pulley system, all right, and number 3, how we actually causes movement, all right, that causes acceleration of object, okay, all right, let's move on to the next one. These are the basic one, huh? We have approximate, maybe 10 slides, okay, all right, these are the basic one. Number 1, all right, coconut falling down, acceleration is 9 meter per second square. Tengok soalan dia. Alright, kita tengok soalan. Alright, okay, everybody ready? Sketch the force acting. Okay, any object, okay, if you let it fall down, show got 2 forces. One going down, weight atau berat. Satu ke atas, alright, air resistance ataupun rintangan udara. Or some people use the word frictional force. Alright, daya geseran. Betul? Alright, so one up and one down. You notice that? Alright, weight, we all know berat. Okay, air resistance, rintangan udara. Okay, so done. We have done A already. Let's take a look at B. Calculate the resultant force. So, F equals to MA. You are given the M and you are given the A. Senang sahaja, betul? Alright, kita just masukkan ke dalam. Okay, this will be your resultant force. Boleh? State the direction. Sure, resultant force should go down. If resultant force doesn't go down, then the coconut will never fall down. Betul ke tidak? Is that correct? Okay, good. Okay, so it will accelerate downwards. Therefore, this is the one that causes the coconut to fall down. And then continuation. Okay, the question is not as short as it is. Okay, so all right. Okay, we repeat the question. What is the magnitude of air resistance? You know the air resistance exists atau rintangan udara wujud. Tapi berapa nilainya? Okay, so what you do now is you're going to come up with. All right, okay, we write down all the things that we know. All right, okay, we know the weight is W equals to mg. All right, which is here. All right, this is your W equals to mg, betul? All right, equivalent to mg. So what we do now is, okay, understood, the coconut fall down. All right, so understood, your weight must be bigger than air resistance, betul? Kalau dia turun bawah, daya ke bawah mesti lebih besar dari daya ke atas. Remember, huh? All right, object falling down, downward force must be bigger than upward force. So you will take weight minus. All right, you will take weight. Look at the equation, huh? All right, okay, not yet. This one, this equation. Weight minus resistance. Okay, huh? So all those you just put it in. All right. Okay, do you notice that I have calculated W for you? All right. Okay, because you are given 9.81. So this W we are going to put over here. And resultant force just now we calculated, remember? Resultant force F equals to MA, the earlier question. We are going to put here, remember? 2 times 9, remember? We're going to put over here. All right? Okay, or we are going to put over here. Boleh ingat? So I put in the value, huh? All right, I put in the value. 2 times 9, remember, is a 18. All right, 2 times 9, remember, is a hang on. All right. Okay, I want to erase one of my, hang on, okay, I'm going to make it bigger. All right, okay, it will be all right. Okay, so what I do next is I am going to put in the value. All right, okay, you notice that, okay, I put in the value, resultant force 18. All right, once I put a resultant force 18 here, all right, and the weight, okay, I put in here 19.62, which actually come from here, betul? All right, betul? And then you just rearrange it, okay? Minus R to the left side become positive. Then 19.62 minus 18. Because 18 is positive, go to the right side, become minus. Boleh? That's how you get your R. Okay, this is only one example. Huh? We're going to move to the second example. Everybody, please make sure. I know many students are not good in lift. All right, so today we are going to make sure in any situation, all right, in object in a lift, there will be 2 forces. One will be weight, W going down. One will be normal reaction going up. Okay, so when a girl stands on a platform, there are 2 forces acting there. You notice that? So the 2 forces you can see in the diagram. One is W, okay, weight atau berat. One is R, normal reaction. Bahasa is called, okay, daya tindak balas normal. Okay, so in any situation when there is no movement, tak ada pergerakan, then dua-dua daya ini mesti sama. The downward force must equal to the upward force. Alright? And then it will be balanced. Boleh? Okay, huh? So now we're going to look at situation when it start to, it's still not moving, huh? Stationary. Okay? So stationary understood. Okay? This is the first drawing. Okay? So understood, R equals to mg, betul? Already mentioned. Alright? When it is stationary or when it is moving uniform speed. Alright? So what is the meaning uniform speed? Acceleration is going to be 0. Betul? I show you the equation. Huh? So we actually apply this formula. Alright? So whether it's going up or going down. Alright, going up. Okay, let's take a look at this drawing first. Okay, huh? Alright, going up. Going up meaning what? R more than mg. Okay? So R more than mg, so what I do is I will have R minus mg. That is your resultant force. Alright, that's your resultant force. Boleh? Then F equals to ma. So what I do is I put in the A equals to 0 into my equation. Alright? I put A equals to 0 into my equation. Alright? Okay? You will be able to see what? Alright? You'll be able to see 0 equals to R minus mg. So my R equals to mg. Clear? Alright? So look at this, the next diagram. Okay? Object falling down. Mg is bigger. So resultant force? Mg minus R. Boleh? Alright? Boleh Then F equivalent to ma. Boleh? F equals to ma on the left side. Alright? Masih ingat? A masih kosong? A masih kosong, kita masukkan. A sama dengan kosong ke dalam. So you eventually you will get R equals to mg. Boleh Alright? So whether it's in the stationary or, okay, when the leaf is moving with a uniform speed, alright, the acceleration is 0, then the reading of the weighing scale is always equals to mg. Always remember, kalau soalan tanya reading, okay, reading of weighing scale, okay, reading of weighing scale maksudnya bacaan, okay, kita kata bacaan scale pemberat, okay, nilai yang kita cari mesti sama dengan R. Ingatlah? So the R is equivalent to mg, R equivalent to mg. Alright? Okay? Masih ingat? So with that, I am going to move to another slide. Okay? I'm going to move to another slide. Alright? Look at the bottom one. Reading of the weighing machine equals to the weight of the girl. Okay? Alright? Okay. Okay, now we'll look at going upward. Okay, going upward, which is bigger? Understood? R bigger. Alright, so your resultant force R minus mg. Betul? Alright, going up, you notice the word up here. Alright, okay. Okay, hang on, I erase because it's not moving. Alright, going up, what happened? Okay, R is bigger. So your resultant force, always start with resultant force. Alright, resultant force, how do we write resultant force? Fr. Okay, what did I mention just now? What did I mention? Going up, right? Going up, R bigger, betul? R lebih besar, betul? Kalau R lebih besar, then R tolak mg. Okay, boleh? Alright, you always follow this, you will never get it wrong. So, resultant force sebelah kiri equals to ma. Boleh? Equals to ma. And then your job is to find R. So, you notice that R equivalent to mg plus ma. Alright, because you are going to move your negative mg to the left side. Alright, okay, so what happened? Dalam keadaan leaf tidak bergerak, R sama dengan mg. Sekarang, R sama dengan mg plus ma. Jadi, kita ada, okay, penambahan nilai ini. That's why the girl will feel that she is heavier. Okay, alright, now we're going to go to the situation when, alright, the leaf is going down. Okay, the opposite. Okay, do you notice the word down here? Alright, okay, alright. So downward, do you see? Okay, the one in we call it blue color. Alright, do you notice the word there? Downward, dapat Alright, so downward, which one is bigger? Terbalik sekarang. Mg bigger. Mg bigger. So it's going to be mg minus R. Okay, alright. Let's take a good look. Hang on. Okay, we know that going down, mg is bigger, betul? Alright, going down mg bigger, so we will have mg, your resultant force, mg minus R. Okay, what did I mention just now? Resultant force on the left side, alright, F must be equals to ma, betul? Alright, then you akan buat susunan untuk mendapatkan R. Every time bacaan this one scale pemberat, it mesti cari R. Okay? So my R is mg minus ma. Alright? Betul? So you notice that it decreased by ma. That's why this girl will feel that she is going to be lighter. Boleh? All right, this girl will feel that she is getting lighter. Boleh? All right, huh? Then we're going to look at another object, another drawing. Okay, all right, let's take a good look. Okay, calculate the magnitude. This one example, huh? All right, when it is stationary. Masih ingat stationary? Stationary, your bacaan R sama dengan mg, betul? Alright, so if G is given as 9.81, you masukkan nilai lah. Boleh? Masukkan nilai. Okay, G equivalent to, we call it, hang on, I get a color first. Okay, huh? Boleh? Alright, you look at the second question. Now move upward. Sebenarnya ulangan apa yang kita buat tadi. Alright, jadi upward maksudnya apa? Understood? R bigger. So resultant force R minus W. Betul? R minus W. What is W? W is sama dengan mg lah. Betul? Kita masukkan nilai dalam. On the left side, F equals to ma. Alright, and you are given the A, betul? Nanti you masukkan. Alright, you susun dulu, get your R first. Alright, R equals to mg, ma plus mg or mg plus ma. Masukkan nilai, then you akan dapati nilai lebih besar. Is it okay? Alright, boleh ha? So kalau boleh, we will continue ha? Alright. Okay, 3 minutes. Okay, now let's move. Calculate the magnitude of the normal when it's going down. Okay, all right. Okay, is it going down? Let's read. Huh? All right, calculate. Okay, when the leaf is moving with a uniform. Oh, uniform velocity meaning what? Uniform velocity meaning your reading equals to W equals to mg. Clear? Because remember A equivalent to 0, betul? All right. Okay, that's why it will be sama dengan mg. Now downward. Downward W bigger, betul? Then resultant force. All right, equivalent to W minus R. All right, resultant force. W is mg minus R. All right, and then on the left side, F equals to ma. Then you rearrange it so that your R equals to mg minus ma. All right, and then you put in the value, you get a smaller value. This value is smaller than the actual weight of the person. All right, that's why budak itu akan rasa lebih ringan. Boleh? All right, now I'm going to show you one more question on system of the pulley. Okay? All right. Okay, this boy is pulling. All right, a force pulling a mass over the pulley. Then the tension is given as a T here. All right, and a T here. Okay, so let's take a look at the question. All right, find the tension of the rope when the bucket is stationary. All right, so stationary means what? Not moving, you know. So understood? It is what? W equals to mg lah. Betul? All right, W equals to mg. Okay. Hang on a second. Huh? All right. Okay. W equals to mg. Why we put T sama dengan mg? Because upward force and downward force must be balanced. Okay, huh? All right. T equals to mg. All right. Okay, and we know because of stationary. Okay, or it moves with a constant velocity, A is 0. That's why kita masukkan A kosong sama dengan kosong dalam ini. So your answer will be sama dengan berat, which is mg. Okay, huh? So the continuation. Now, upward. Upward meaning you start with T. T bigger. Alright, we only look at this system on the right side. Jangan tengok sebelah kiri, tengok kanan. So understood. Going upward. Okay, I draw the arrow going upward. So going upward maksudnya T lebih besar. So you start with resultant force. T minus mg. Clear? Tengok ini ya. T minus mg. Alright. So on your left side, resultant force or net force equals to ma. Then you arrange it so that your answer, your subject is a T. Because question asks you to find T. Betul? Alright, question asks you to find T. So you get equals to mg plus ma. Kita masukkan nilai dalam. Alright. So mg, remember 30 tadi, remember mg? Plus m is 3 kilo and a. So you get a bigger value, okay? Because of the presence of acceleration in the system, okay? All right. So, of course, we have other example, all right? But I think I'm going to share with you in the next lesson, all right? Okay, because this is going to be quite a long lesson, all right? Okay, with that, I think we will come to the end of this session. All right, in the future, I will be giving you, I just show it to you so that you can expect what to get. All right. Okay, there are actually 4 more slide to 5 more slide. We do it in the second session. Alright. Jadi kita akan bersama-sama lagi dalam sesi Jom Heboh SPM. Okay, sesi yang akan datang. So dengan harapan murid-murid dapat mempelajari sedikit sebanyak tentang kaedah yang betul ataupun yang kita kata paling tepat untuk menyelesaikan masalah keseimbangan. Alright, so I hope everybody will grab their slightest slight idea how to solve question on. We call it equilibrium of forces. Alright, with that, I will come to the end of the session. Jom Heboh SPM this time. I will see you in the following session. Alright, there are 4 or 5 more slides. Okay, see you then. Bye.